Hello, good morning, everybody, and ladies and gentlemen, and good evening if you are connected from Asia, or maybe good night as well in some part of the world. So today the presentation that I'm going to introduce you is about a maintenance, how a good quality lubricant maintenance program can improve and increase the performance and reliability in your compressor. This is a topic that is not always clear or known to everybody, so I hope that you will find it interesting. Okay, so this is the agenda for today. We will go through what is the varnishing and what is the two-measure impact on varnishing, especially on bearings and on valves, control valves. Then I will let you know what is the connection between increase of temperature and increase of vibration in your bearing. And then finally, we will go to the topics that is about how you want to monitor your oil and eventually how you can solve the problem if you have a problem of varnishing in your system. Last but not least is a couple of case studies which will help you to understanding better what I just presented you. Okay, what about varnishing? What is varnishing? Maybe you heard about that a few times. Varnishing is an organic compound which is byproduct from oil that you have in your system, and the varnishing can be in different consistation, so it's a different format, different color, and of course there are even different chemistries that makes up the deposit, and these chemistries are mainly based on how the condition of the machine is operated, what is the formulation of the oil, and if you have contaminants, hard contaminants or gas contaminants, in which they influence the oil degradation. So mainly there are four mechanisms which they produce degradation in the fluid. So first, which is always happening, is oxidation. So oxidation is when the oil is in contact with air. So the oxidant which are present in the oil slowly will be depleted, and then will be the formation of varnish. Then there is a thermal degradation, which is due to sparks discharge or microdieseling, hotspots, but it's not what we are going to talk today. Then is which is mainly common in compressor, especially in Syngas compressor. So is external contaminant like gas, for instance, ammonia, or solid particles, or even water, when you are talking about steam turbine, for instance. And then you have incompatibility. What is incompatibility? Incompatibility is when an oil is mixed with another oil. So this is very important because most of the times there are like oil company which is telling you that you can mix, oh, this oil is totally compatible, but it's essential that we keep a very firm rule. So the lubricants need to stay isolated from other lubricants. So this is like how is happening now in many places due to lockdown. But the incompatibility is the first sign that you can see when you have two oil mixed together. So it's creating then most likely varnishing. Even the same oil sometimes is change a little bit. Like all the formulation of oil with the new formulation of oil, exists same oil, sometimes it can be incompatible and accelerate the varnishing production. What we talk about varnishing, I told you what is the cause of varnishing, and then now we can see a little bit of picture of varnishing. So varnishing can be like gel. We see picture where there are black, or can be a lacquer, orange lacquer, or can be even other color like purple or green or yellowish. And all of this is varnishing. So it's an organic product which is coming from the degradation of your oil. So when you have a problem, and then now I'm talking more in specific, when you find a problem on your bearing, so actually it can be a mechanical problem, but we found even almost 50% of the time that this problem is due to chemical change in the composition, in your oil. Of course, chemical changes, which is maybe due to some other mechanical problem, but these two are correlated. So what we now see is that temperature exclusion and wear are both caused by mechanical issues and chemical changes in the oil. So what is the measured impact of varnishing? Actually, there are two measured impacts. One is the increase of wear, and the other one is the temperature excursions. So why increase of wear? Actually, the varnishing is a polar compound, and is depositing on the metal. So they really like varnishing. Really likes to be attracted and depositing on the metals of, for instance, of the bearing. And this compound, of course, change the film of oil which is created between the rotor, for instance, and the bearing itself. So changing this is creating at the end, is disrupting the hydrodynamic oil and these inconsistent oil flow patterns. So at the end, eventually, this is creating a crack, hydrodynamic crack, which is can bring metal in contact again with the other side of the metal, so rotor in contact with the bearing. And then, of course, when this happens, is removing part of the metal, the protection on the bearing. And this is some picture which is showing you what happens. So the evidence of varnishing, which increasing wear rates. So I mean, there are all these picture, which is pinion bearing. You have a side where you can see the black and orange. This this is where the varnishing has been deposited. And this is okay, quite extreme, but this is a journal bearing where it's very visible the sign of wear due to this contact metal to metal. Another 4 pictures about bearing and wear contact. The second problem that the varnishing can cause on the bearing is the increase of temperature. Why is this increase of temperature? Well, another properties of the varnishing that is a very good insulator. So it's preventing lubricants from performing probably one of the major tasks, which is the cooling. And so this is creating kind of layer, which the varnishing is creating a layer between the bearing and the oil, and this is what is avoiding the cooling effect. And this is how you can see that. Actually, I will show you some graph, but this is the signal that this is happening is normally what you see a sawtooth graph in the temperature graph of the bearing. And this is the typical graph. So at the beginning is just a little bit, few degrees. So few, actually less than a few degrees. And then it can goes up quite quickly. Why this is trend up and down? Well, yes, this is due mainly the fact that the varnishing is increasing. So this layer is increasing, and then is wiped off. But I will show you a couple of slides which explain you better. Another important factor is that temperature is very well connected to the position of the rotor. And so we found the correlation between vibration as well and temperature. So we found that where there is a spike in the temperature, then we have as well different position in the vertical shift in the rotor position. So there is a correlation between these two. And this is why there is correlation. After studies, we found out that, of course, this is the oil film, this is the rotor, and this is where the varnishing is, the first layer of varnishing is created. Well, if we increase the temperature, because of course there is no more dissipation, so the temperature is increasing and other varnishing is building up, so there is even more temperature increase. But building up the varnishing, the oil film is changing, so there is the clearance that you have between the rotor and the bearing is different, and the rotor position is changing, is going up. Then other varnishing is building up, and more varnishing, more insulation, more temperature, and the rotor is going up even more because, of course, different oil film. When finally reach a point where the force to move the shaft becomes greater than the film strength of the deposit, then at that point the varnishing layer is wiped off. And the rotor return almost, I would say, almost to the original position, because there is always some little bit different. And the bearing temperature, of course, goes down because the layer of varnishing. So that is the correlation between the rotor and the temperature. This is what we discussed about bearing, but the similar problem is not similar, but varnishing is creating another problem as well in the valves. Why in the valves? Well, you know, varnishing is properties of the varnishing that when the oil is hot, I mean over 60 degrees, the varnish tends to stay in solution, so it's soluble. So this is chemistry. So when there is warm liquid, it increases the solubility in this case. But in the valves are intermittent. So there is part of the oil which stays in the same position and is cooling down quite quickly because there is not like a lot of oil. And when it's cooling down, there is much more probability that the varnishing is getting out of the oil. So it's depositing. And this, where it happens, for instance, in the small clearance of the valves. And eventually, this makes that the valves stick. So when you try to move the valves, you cannot move the valves anymore. We calculated that what is the typical cost in case of a trip. So you have, can be even between $30,000 and $200,000. This has been calculated for a full road trip, or can be as well a condition that the machine is not starting because maybe after hours that it was a shutdown, or because the machine was used only partially, only maybe intermittent. Then you try to start and there is a fail to start condition because the valves is not moving. And this can cause even like more, up to $300,000. Or this is okay. This is a power generation. So it was a power plant in South Africa. This is the case of overspeed valve. So unfortunately, in this case, there was an overspeed and the valves didn't close because it was due to this varnishing. And then this is what happens. Okay, now we want to move on the topic. Is we saw what is varnishing, we defined what can be the problem of varnishing, and now we see how you can know if the varnishing is in your system, how you can monitor, and then we will see how you can solve the problem. There are several tests which is telling you the condition of your oil. Is like a blood test. So when you want to see the condition of your body, you go to the doctor and then you make a blood test. The similar you do with the oil. So, but when you talk about varnishing, one of the most important is the MPC. The MPC is a membrane patch colorimetry, so it's giving you very simple the idea how much tendency of varnishing you have in the system. So when you see a clear patch, so below 20, meaning that the varnishing is not present in your system or present very lightly. And normally we consider above 35, 40 like a critical threshold where you really need to take some action because you are building up too much varnishing in the system. Another important test is about what is the lifetime of the oil. This is something that is not done or performed very often because it can be a little bit more expensive, or there are not very many labs that they have this technology of the ruler, even if it is a sample technology. But is this ruler this test can save you a lot of money because it's giving you the lifetime of the oil. So it's telling you if the oil can still stay in the system or if you have to change. So you can imagine that instead of changing the oil every 1, 2, or 3 years according to your maintenance plan, maybe you can prolong the oil in your system 1 more year. So this is, you can save quite some money in the long term. And it works very simply, like it's comparing the amount of antioxidant in the existing oil with compared with a fresh oil. So same oil but fresh. So it's giving you the percentage of antioxidant. Antioxidant are the protection. Like if you consider like an apple, the antioxidant are the skin of the apple. So it's what is protecting you the oil from, is preventing you from making oxidation. Normally, in your oil, you have 2 kinds of antioxidant, which is amine and phenol, and this ruler is giving you the percentage of this antioxidant. But there are many other tests for the soft contaminants. You can see MPC. You have the ISO test for the fluid degradation. As you said, we have the ruler. Or you can check as well what is the compatibility with the contaminants. So, and then you go for a foam air release or water emulsibility. So when you have all these tests, we can tell you, like, yes, your oil, we can individuate what is the root cause, if there is any, and what is the status of the oil. Okay, now let's go quickly on how you can solve the problem without shutting down the machine. So how you can remove the varnishing from your system. There are 2 FLUITEC developed two products. One is about filtration technology, and the other one is what we call it solvencer technology. So the filtration, it looks like many other filters that you may have. So it's a kidney loop filtration where your oil is processed and going through these 2 filter elements. So the difference to many others that FLUITEC is using since many years special resins as a media. So these resins, they have the properties to absorb the varnishing in the oil. So if you remember, I told you that varnishing is a soluble organic compound. Well, when the oil, which is normally is about 60 degrees, this varnishing is into the oil. So it cannot be catched by a depth media filter because it's not a hard soluble. So it's not hard contaminant. So you need something different. And then actually this media, these resins can absorb this varnishing, and the varnishing is at the end free of, the oil is free of varnishing, maintaining additive in your oil. But the second, the other method that FLUITEC developed is about increasing the solubility of the oil. So the varnishing is a byproduct of the oil. It's an organic, but more important, that is reversible. What happens in your oil can be reversed. So the varnishing can go back into the solution if the solubility of the oil increase. And this is exactly what the solvencer technology does. Solvencer is a totally compatible group 5 oil, which is added to your oil in a percentage, normally about 5%. And what it does is increasing the solubility, and increasing the solubility is removing layer by layer the varnishing from your system, and without creating any hard contaminants, any damp, because it's absorbing the varnishing that was on the layer on the metal again into the oil. So it's catching getting back what the oil released during the time. And in quite a relatively small amount of time, we are talking about weeks, normally the system is totally cleaned. System is cleaned in weeks, but effect of this can be very, very fast. So we found, and then I will show you in the cases that if you have problem of temperature or problem of vibration, this can be solved in hours. So it's very quick process. So if you think about an oil, the solubility of the oil, which is like this one at a certain temperature, if you increase the temperature, the solubility of the oil, so this bucket increases, so it's more soluble, but you cannot like increase the temperature. This is not a factor that you can do, you can play. So, but with the solvencer, this is what happens. So we increase the bucket in a way that it can collect much more quantity of varnishing. And together with technology or ESP, not only remove the varnishing, but maintain the quality and the antioxidant of the oil along the time. Okay, a couple of these case studies just to show you more in details what I was just explaining you in this technology. So this happened in the compressor, in a cracked gas compressor in a refinery. So when they called us, it was not really critical because in terms of varnishing tendency, so it was 22, so it's abnormal, but it's not critical. Then after one single day, the MPC of the oil, thanks to our solvencer, dropped to 1, and 4 weeks later, it was still to 3. So this, because the solvencer technology acts very fast in the oil, and in few weeks, it will clean the system. And the same you can see as well in the temperature trend, where this was the sawtooth, typical sawtooth, which when the Deacon, one of the solvencer product, has been applied, it practically went down at the normal level and stay stable for from that moment on. And then it can stay in the system. This oil, the additional oil, this solvencer, is not only compatible, but can stay in the system as long as you like, years, till the new shutdown, till the change of the oil. Another one was this fertilizer plant, and they have again a similar problem. So they called us, they have again the temperature in the bearing that it was going up and down. So they were asking what was the problem. We told them about possible sawtooth. We made an analysis of their oil. And when finally they used the solvencer of the product, it was immediately a drop, but immediately it talks about hours, and it stabilized. This is when the solvencer was added, and what happens from that point on. Okay, so the conclusion is the varnishing is often the cause of bearing temperature excursions. So, and then you can see normally with a sawtooth temperature trend. You can control the varnishing in your system. So, and then you have a different method for monitoring the varnishing, MPC, ruler, and many other tests. And there are technology, we have technology, proven technology, so sold more than hundreds around the world for control the varnishing, removing the varnishing, and return the bearing temperature to the normal temperature. And this is made without shutting down the plant. So in real, it's saving you the money, not only because it's protecting your system, but because it's preventing you to shut down the plant. I'll leave you with these slides, which I hope that you like. Is giving numbers. I know there are a lot of numbers here, but our concept is feel for life. So what FLUITEC wants to do is creating a system, which an oil system, which can stay an oil, which can stay in the system forever, like for the lifetime of the machine. We have even our own product. The name is Infinity, which can stay in the same. So what we want to do is we want reduce the outage of your machine. We want to maintain your oil, and we want, of course, at the end, save even the environment, because you don't have to change the oil, and you can reduce the amount of oil that you at the end dispose in the environment. I hope that you like the presentation, and thank you very much for listening.